Okay. Okay. So let's look at number 1. I'm going to go ahead and work these problems on my iPad. Okay. So let's look at here. Okay, ducks. Okay, so let's look at the first problem right here. It says identify the set as integers, natural numbers, and whole numbers. Okay, so remember integers, those are your negative numbers like -3, -2, -1, 0, 1, 2, 3, and so forth. Okay. Natural numbers, so those are your counting numbers. So like 1, 2, 3, and so forth. Whole numbers are numbers that 0 and then 1, 2, and 3. So those are like your natural numbers, just including 0. Okay, so here we notice we have 0, 1, 2, 3, 4, and then a negative. So that would fit integers. All right, so number 2. Here, determine if the set of ordered pair is a relation or a function. So if you look at a regular graph and you have a line, how do I know if it's a function? You would do the vertical line test, right? And we notice it only hit the graph once. Okay. If you had something like this, okay, if you notice it hits this many times when you do the vertical line test. So if you look, those are repeated x values. And that would tell us if it's just a relation. Okay, so we're going to look at the x's right here. And if you notice, we have a repeated x value. So that means it is a relation. It is not a function. Okay, number 3, a blank is a mathematical expression consisting of constants and variables combined with the operations of, and let me see what that's supposed to say. That is of addition and multiplication. Okay, and that is a polynomial, a mathematical expression. So for instance, like this, 2x plus 3y plus 40z minus 300. Okay, it's an expression that consists of constants, like 300, constant, variables, combined with operations of addition and multiplication. So this is the multiplication that's happening between the coefficient and variable, and that is called a polynomial. Okay, number 4, a relation in which each domain element is paired with exactly one range element is called a function. Okay, so just remember, domain are the x values, range are the y values. So each x only has one y. Okay. Number 5, solve the linear inequality. Okay, so this is similar to if this was an equal sign. We are solving for x. So let me just rewrite the equation. -10x plus 3 is greater than x minus 19. Okay, so again, pretend that's an equal sign instead of a greater than. We're going to draw a line. And we're going to go ahead and solve for x. So first, we're going to have to move one of the x's over. I'm going to go ahead and move this one. And since this is a positive x, you subtract x on both sides. And so we get negative 11x here plus 3 is greater than, and that just cancels out, that's 0, to negative 19. Okay. Next thing I'm going to do, so I'm trying to get x by itself. I'm trying to get x by itself. I am going to move the 3. And since it's adding through, we're going to do the opposite, which is subtract 3. Okay, on both sides. And so this cancels, right? That gives a 0. And then we're left with negative 11x is greater than negative 19 plus or minus 3 is negative 22. Okay. Okay. The x is still not by itself. It's getting multiplied by that coefficient, negative 11. So if it's getting multiplied, the opposite would be division. So we would divide both sides by negative 11. That cancels, and we're left with x is greater than positive 2. And that would be this one. Okay, number 6. Okay, we're solving the linear equation. And I'm just going to rewrite. Oops, go ahead. So negative 7x plus 15 equals x minus 9. I'm going to draw a line where the equal sign is. Okay. So what am I doing here? I am going to combine the x's. So I have to first move one of these x's over. Let's go ahead and just move this on. So plus 7x. So we're left with 15 equals 8x minus 9. Okay, move the 9 over. So we're going to add 9 to both sides and get, what is that, 24? Okay, remember we're trying to get x by itself. So now we're going to, divide by 8. Remember that coefficient, that number is getting multiplied to the variable. So we're going to divide. That cancels. And we get 3 equals x. Or you can write it as x equals 3. Okay, number 7. Okay, so here we have two polynomials. Or we actually have a binomial. This is called a binomial. And this is a poly because it has more than 2. Nomial. And they're getting multiplied. So what we're going to do, we're going to double distribute. Okay, so what that just means is I'm going to take this first term and I'm going to multiply everything in that polynomial. So we get x times 2x squared, which is 2x cubed. And then x times x, negative x is negative x squared. X times 3 is 3x. Okay, and then we're going to do it with the second term of the binomial. We're going to multiply each here. So 1 times 2x is 2x. 1 times negative x is negative x. 1 times 3 is 3. Okay, now we're going to combine like terms. So there's only one term that has x cubed. Here we and 1x squared. Okay. So here we have 3 like terms. 3, 4, 5 minus 1x is 4x plus 3. I think I did something wrong. What did I do? X squared minus x squared plus 3x, 2x minus x plus 3. Hmm. So we have 2x squared minus x squared plus 3x. And this should be squared. Whoopsies. Okay, let's fix that. Okay, so here's x squared, so we are left with x squared and plus 2x plus 3, and so that would be, I believe it's this one. Okay, so next one, simplify. Okay, so here we're going to distribute. We're going to distribute the minus sign. So we're going to have 2x squared plus 4x squared minus x. And combine like terms. So that becomes 6x squared minus x. That's our answer. Okay, let's move down to number 9. We want to identify the equation. So this is a line. So we know it's going to be in some form, like mx plus b. So we need slope, and we need the y-intercept, which is m, and this is b. Okay, so y-intercept, you're going to find on the y-axis, which is right here, that point, -4, 0. So we only want the, whoops, that is wrong. It's 0, -4, so we just want the y. That's -4. And then we're going to use this point, or you could have used this point, or you can use this point. Doesn't matter. Just make sure it's a whole point, meaning there's not a decimal point, doesn't have any decimals, no fractions. It is a integer. Okay, so we can just do this 1, 2. So it's going 2 down and 1 to the right. And since it's going down, there's a negative. It's going to be -2 over 1, because remember it's rise over run. And so our equation, when you fill that in, is y equals m is -2x minus 4. So now let's look at Number 10, find the x-coordinate of the vertex, y-coordinate of the vertex, and x-intercepts. So here's our quadratic. It is in standard form, meaning it is the form of ax squared plus bx plus c. Right, so to find the x-coordinate of the vertex, it's going to be negative b over 2a. So what is b right here? It's going to be negative 2 over 2, and then a is a 1. So we have negative 2 over 2, which is negative 1. So the answer here is D, negative 1. Okay, and how do we find the y coordinate? Well, all you have to do is just plug in. So y, because we know what x is, negative 1 squared plus 2 times negative 1 minus 3. That's 1 minus 2 minus 3, which is negative 1 minus 3. I'm going to combine those, and then negative 4. So that is the y value, which is C, negative 4. Now we're trying to find the x-intercepts. We can do that 2 different ways. Here's one way using the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we already know what b equals. B is 2, a is 1, c is, what is it, negative 3. Okay, so we have negative b, which is 2 plus or minus 2 squared minus 4a times c all over 2 times a, which is 1. Okay, simplify that. Negative 2 plus or minus the square root of 4 minus or plus 4 times negative 3 is over 2, which equals negative 2 plus or minus the square root of 16 over 2. It simplifies to square root of 16 simplifies to 4. And then we have 2 answers. So one we're going to be adding 4. Negative 2 plus 4 divided by 2, which is negative 1. And the other one, which is negative 2 minus 4 over 2, which is negative 3. Did I do that right? Sorry, this would be positive 1. Okay. The second way is to factor. So we have our x squared plus 2x minus 3 set to equal to 0. And then you look for factors of negative 3, which is like 1 times negative 3 or negative 1 times positive 3. And then we look to see which one will add up to b, which is 2, which would be this one. So then you set them up. X minus 1 times x plus 3 equals 0. Set each factor equal to 0. Solve for x for each of them. We get x equals positive 1 and negative 3. So that is this one. Okay, so number 11, find the solution for the quadratic inequality using the quadratic formula to find the roots. Okay, so this is in standard form. So remember ax squared plus bx, a equals 1, b equals 1, c equals negative 12. And we're going to do the quadratic formula, which is negative b plus or minus the b squared minus 4ac divided by 2a. Okay, we already know what b is, so it's negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 12 divided by 2 times 1. That's negative 1 plus or minus the square root of 1 plus 48, which is negative 1 plus or minus square root of 49 divided by 2, which is negative 1 plus or minus 7 divided by 2, which we're going to get two answers. X equals, I believe it's negative 4, and x equals 3. Okay. Okay, so now we're going to create a number line. We're going to set 0 right there and negative 4, which is somewhere here, and negative 3 is right here. All right, so we're going to use some test values to see how, or to find where the x values are located. Are they going to be between them? Or are they going to go in opposite directions? Meaning, are my x values going to be like 4, 5, 6, and negative 5, negative 6, and so forth? So let's use some test values. So first, let's use 0. So that means to test it, we're going to plug them in to our equation. So 0 squared plus 0 minus 12. Is that less than 0? Negative 12 less than 0? Yes. So this checks out. That means, so far I'm going to have values between negative 4 and 3. Okay, and then just to check, what if I use negative 5 to see any values? Negative 5 squared plus negative 5 minus 12. Is that going to be less than 0? So what would we get? We get 25 minus 5 minus 12, which is a positive number. And are positive numbers less than 0? No. So we know it's not over here. And then using positive 5, that's also going to give us a positive number, which is not less than 0. So that is our answer. So x is between the values negative 4 and positive 3. So it's this one. Oh, sorry. No, that's not that one. It's this one. All right. Then we're going to move on. Number 12. So find the discriminant of the determinant to the following roots, then solve the quadratic equation using the quadratic formula. Okay, so the discriminant, so when you're looking at the, what's it called? The quadratic formula, discriminant is the part that's under the radical or under the square root, which is b squared minus 4ac. Okay, remember this is in standard form where a equals 1, b equals 1, and c equals negative 6. So what's the discriminant? Well, just plug in our values. 1 squared minus 4 times 1 times negative 6. That gives us 1 minus or plus 24, which is 25. So our discriminant is 25, which is A. Now to determine the number of roots, we look at this value and it's greater than 0. So if it's greater than 0, it has 2 real roots. That'd be C, 2. This is A. Okay, if the discriminant is less than 0, it has no real roots. And then if it's equal to 0, it would have been 1 repeated root. So we're going to move on to using the quadratic formula. As x equals negative b plus or minus the square root. I can take her. No, I can take her. I don't. Equals b squared minus 4ac. That's where the discriminant is. 2 times a. Plug in the values. We have negative 1 plus or minus the square root of 1 squared minus 4 times a times c over 2 times a. That's negative 1 plus or minus the square root of 1 minus plus 24 over 2. And well, we already did that, so we already know that is 25. And then our solution, so we're adding 5, so negative 1 plus 5 is 4. We get 2. And then we subtract, that's 6, so we get negative 3. So that is a G, 2 and negative 3. Okay, so next one, solve the equation, determine the solution of and any extraneous solutions. Okay, so extraneous, this means the extra one, the one that doesn't fit. That's useless to us. Okay, so we'll start with the square root of 2x equals x minus 4. And what we're trying to do, we're trying to solve for x. So anytime you have a square root, when you're solving for x and there's a square root, you want to isolate the square root. So make sure it's isolated, meaning it's by itself on one side of the equal sign. And go ahead and do this, which that one is already isolated. And one little tidbit y'all should know is that the square root, another way to write it is as an exponent of the 1/2. And to cancel that, so we have something x to the 1/2, to cancel it, you would square it. Because when you have a power to a power, you multiply those. So 1/2 times 2, which just gives us 1, x to the power of 1. Okay? So that is what we're going to do here. We're going to square both sides. And what happens when we square both sides, that cancels out the square root on one side. So we're left with 2x equals x minus 4 squared. And if you remember, we're going to expand that. So this exponent square tells us how many times we're going to be multiplying the base by itself. So that's x minus 4 times x minus 4. And I mean, we would FOIL or double distribute, and we would get 2x equals x squared minus 4x, which is minus 8x plus 16. Okay, and then we're going to go ahead and move the 2x to the other side. So we're left with 0 equals x squared minus 10x plus 16. Okay, then we would factor. So we're going to look factors of c, which is like 1 times 16 or negative 1 times negative 16. 2 times 8 or negative 2 times negative 8 gives us positive 16. And then 4 times 4 or negative 4 times negative 4. Now we're trying to find which factor pair, when we add it up, gives us negative 10. And that would be this one, negative 2 plus Negative 8 gives us negative 10. So then we're going to go ahead and make our factors x minus 2 and x minus 8. Okay, set each factor equal to 0. We can do that since these factors are multiplying, by the way. And we get x equals 2 and x equals 8. Okay, so those are solutions, but one of them is extra, and we don't know which one yet. The way we do that is we check by plugging them in. So we remember the equation 2x equals x minus 4. Let's do one where it's 2. So we plug in 2. What do we get? We get the square root of 4 equals negative 2. 2 equals negative 2. That doesn't work. So this one might be the extra one. But I'm going to double check by plugging in the 8 this time. So that's square root of 16 equals 4, which is 4 equals 4. That checks out. So our solution is 8. The extra one is 2. Negative 2. No, 2. Sorry. This one. Okay, last one here. We want to find the inverse. So to find the inverse, we switch the x and y. We're going to switch that. We're going to have x equals the square root of 2y minus 5. Okay, solve for y. Square both sides equals 2y minus 5 plus 5 divided by 2. We get y equals x squared plus 5 divided by 2. And that is it for the KA. Well, none of y'all showed up, so whatever. I wish y'all good luck. And I might be able to record this later for better quality video, and hopefully y'all get these Ks done. Okay, I'm gonna stop recording.